Good morning, one and all. Welcome to the session on data mining. We have been looking into the data cleaning process earlier. So, in the knowledge discovery process, our idea of using data mining is to gather knowledge from heaps of data, and using this knowledge, we are going to plan or strategically take decisions. So, the intention behind data mining is to make use of the data available in the organization for proper decision making. Now, if we have this in mind, we can look at our methodology. We started with the data cleaning process. We identified what are the different sources of uncleanliness in data, and then we have removed uncleanliness, and then we gave some clean data for integration, and we integrated multiple sources of data. While integrating, we see that the volume of data becomes very huge for the system to handle. Even if you take mainframe systems, you need to provide reasonable amount of data so that the mining process is efficient. So we have been looking into some of the data reduction methods. Data reduction means finding a reduced representation of the data set that is much smaller in volume, but yet it produces the same or almost same analytical result. And we have seen that the data is represented in the form of rows and columns in a database, each row representing a data object and all the columns representing attributes or dimensions. So, in data reduction strategies, the first form of data reduction is called as dimensionality reduction, where we remove the unimportant attributes as a whole. So, the entire column can be removed based on the dimensionality reduction method. We have seen methods to identify such irrelevant attributes. One is using the wavelet transforms. Wavelet transforms identifies which are the most important attributes, or it tries to represent the attributes in frequency domain, which reduces the size of the data. And in principal component analysis, we try to identify out of all the n attributes we have, which are the most principal attributes, and we use only those principal attributes for data mining. And then we looked into feature subset selection. Feature subset selection is where you identify a subset of the entire set of features or attributes that are not correlated with each other or that are independent from each other. So we looked at some correlation analysis methods, the chi-square test, the Pearson coefficient, and the covariance matrix are used to identify correlation between different attributes. Once we identify that two attributes are correlated to each other, we can remove one of that attribute and perform the data mining holding on to only one of those two attributes. So if you have 50 attributes and find that 10 of them are correlated with one of the other 40 attributes, those 10 attributes can be completely removed with, and the rest 40 can be used for data mining process. This identification of the attributes that are important and uncorrelated is called as feature subset selection. Till here we have seen in the previous session. Now we are going to see how we can reduce the numerosity of the data that we have, and we are going to see how we can still reduce the volume of data that we have obtained. So methods such as numerosity reduction and data compression are used for reducing the volume further. So this is what we have seen on wavelet transforms. and principal component analysis. This is correlation. We've seen chi-square test, and we have seen how the observed and the expected values are close for correlated values. Then we have seen covariance matrix can be used for numeric data. Now, this numerosity reduction means we are going to reduce the volume of the data by choosing some different form of data representation. Instead of representing the data as 50.111122, I can round off to 2 bits and then 2 digits after the decimal, and I can still make the same analytical result. Such way of reducing the volume of the data by using a different form of data representation is called as numerosity reduction. Under numerosity reduction, there are two different strategies or approaches followed. The first one is called as the parametric method. Parametric method is something where you identify a model for representing your data in hand. Instead of storing every value, you store only the model. So every time the data tries to relate, I can store only the parameters and discard the possible data. This is called as a parametric model. Log linear models are an example of parametric models. And there are non-parametric methods also, that which cannot be represented using the form of a model, but still they have the capacity to represent the data in some reduced form. Methods such as histograms, clustering, sampling, all of them fall under the non-parametric method. Under the parametric model, the first one is called as a regression. We have both regression and log linear models. We will look into what regression is. Regression, as I told you earlier, is nothing but line fitting. Now imagine I have two data variables and I am trying to identify the relationship between these two variables. I understand that the data is correlated with each other, and given the value of one variable, the other variable can be assessed. So such a relationship exists between the two variables in consideration. If that is the case, I can plot the two variables on a two-dimensional graph. The one that is independent is called as the independent variable, and the other one which depends on the first variable is called as the dependent variable. Now, the example which we can use here are age and salary. Now, given the age of a person, it is easier to assess the monthly salary of that person. There are cases which are exceptional in nature that do not fit inside this basic structure, but still most of the other people fit into the same structure. So age and salary can be plotted on a 2D graph, and you identify a line of the form y equal to mx plus b that fits best for all the given data points. Now, this methodology of finding the line that can connect most of the data points is called as regression analysis. So, the objective is to find a line, and instead of representing each of the individual values for salary, I can use only the line coefficients. I identify a line and the m and the b value alone. M value is the slope of the variable, slope of the entire line. So b is the only variable constant, and x is the only variable. So in that case, I can identify these values, and instead of storing the salary as a big number in the database for all data objects, I can remove that value and just represent it as mx plus b of the given value or already existing attribute age. Such is called as regression analysis. Now, for regression analysis, the most common method for finding the best fit of line is called as the least squares method. The least square method means I have got different points of x comma y shown as green color dots on the graph. When I draw a line, the line should have the least possible distance from all the points that are given to me. So I need to balance and draw a line which has least distance from most of the data points, or a line that is able to connect most of the data points. Such a line is called as the best fit line. This best fit line represents the regression line for the given data. So for a particular data, if I have found the regression line, then instead of storing the data, I can store the data of the independent variable, and from the independent variable I can only use this regression line equation of the form y equal to mx plus b and derive the other dependent variable. I need not store one column for storing or saving the salary. I can calculate it directly from the age. So this is one form of regression. So in a linear regression, we are going to try to find out lines of the form y equal to mx plus b. And in multiple regression methods, we are going to find out y values which can be represented of the form b naught plus b1 x1 plus b2 x2, or there are two independent variables based on which I am trying to find one dependent value. Such is called as a multiple regression model. So I can either go in for a linear regression model, or I can go in for a multiple regression model. In a log linear model, there is a curvilinear relationship between the two parameters or attributes. So I can use y equal to ax square plus bx plus c. Such an equation is called as a log linear model. We can use regression for reducing the numerosity of the data. The next model is called as histogram analysis. Histogram analysis is a non-parametric method for numerosity reduction. Non-parametric methods means I cannot represent the data in some mathematical or statistical form. So I have to represent pictorially and identify or derive the values manually. Such a method is called as non-parametric method. In the non-parametric category, we have histogram analysis as the first one. What is a histogram? A histogram is where the entire data can be divided into equal sized bins. So I'm going to bin my data in of equal sizes, or I can construct it based on frequency also. Once I construct the histogram, I can use the mean value of the histogram and replace all the values that belong to the same bucket. Imagine I've got the student database. In the student database, I divide all the students based on the number of arrears. So in that case, if I am trying to group the students, I can say there are 35 students who have 3 areas, and there are 20 students who have 2 areas, and there are 7 students that have only one, that don't have any arrears. In that case, I can represent the data into different buckets based on the number of arrears, and only the number of data objects that fall into the particular bucket is noted for further analysis. Such is called as histogram analysis. This is also one form of data reduction. And then you have something called as clustering. Clustering is very similar to histogram analysis. The only difference between clustering and histogram analysis is that histograms are constructed based on one attribute. So if I have the student database, based on the number of arrears, I can construct the histogram. But in clustering, I am going to use all the different attributes of that student and group the students based on the behavior or nature of the student. So I'm going to use his attendance, his midterm marks, his number of arrears, his university performance. All of these attributes I am going to use and group them into different bins or buckets or clusters. Such a methodology is called as clustering. We will deal with clustering later in the unit 4. Unit 4 is completely on clustering. So for now, you understand that clustering means to identify methods that can group data based on all the different attributes of data. And then we have sampling. Sampling is also a form of reduction. So once I cluster all the data, I can use some representative or a smaller group to represent the entire class. Just like we have picked up class representatives, the two of the class representatives or three class representatives will represent the entire class in front of the mentor. So everything the students have to say is spoken through the class representative. The same way, I can say I can group my data into multiple groups, and from each group I can pick n number of samples and then form my data set. If I run my data mining algorithm on samples chosen from multiple clusters, I will still have the same analytical result as running on the entire data set. So I can perform some sampling to identify or choose different data objects from multiple clusters that represent my whole data set. So instead of using the data representation of all objects, instead of trying to give the database the information about all students, I group the students based on their learning capacity, and from each group I pick 2 to 3 students for further data mining process. Such is called as data sampling. There are different sampling methods, but the key principle in sampling is to use the subset or to choose the data objects that represent your entire data set perfectly. So they should be able to represent your entire class perfectly. Only such samples have to be chosen for further analysis. Only then it will be effective. Otherwise, it will be very, very ineffective. So, in order to avoid ineffective sampling, we are going to use some predefined sampling procedures. The first one is called as a simple random sampling, where you just randomly pick out a few people and call them as class representatives. That is called as simple random sampling. The second methodology is called as stratified sampling. A stratified sampling is where you group the students based on their learning behavior. This learning behavior can be identified from the previous academic years. From each group, there is a group that performs consistently poor in all the university examination, and there is one group of students who perform exceedingly good in all university examinations. So when picking out representatives, you pick one from that group and one from this group, so that the perspective of the entire class can be taken for the further analytical analysis. Such a methodology is called as adaptive sampling methodology or stratified sampling. So these are the different types of samplings methods. The first one is called as simple random sampling. This is where you randomly pick a CR. Sampling without replacement indicates that once you do an analysis on a particular group of samples, it is removed from the entire population. For any further analysis, you don't use the data of those samples which were picked earlier. Such a sampling is called as sampling without replacement. And you can do the same process, replace everybody, put them back inside the entire data set and then do your process. That's also possible. That is called as sampling with replacement. And grouping of students and then identifying people from each group is called as stratified sampling. Stratified sampling is very effective when the data is skewed. Skew means uh, you don't have equal number of samples for all possible user groups. In the case of the class, if I have, say for example, you group students as weak learners, okay, medium learners, and good learners. If you divide them, you will always find that the good learners number is very less, the learner number is very high, and the weak learners number is also less. So you don't have equal number of students belonging to each of this category. Such a data or such a system is called as skewed. If you have exactly the same number of weak learners as the number of good learners and as the number of medium learners, then it is called as uniform data. In real world, most of the data is not uniform. 99% the data is skewed, which is why we need to go for stratified sampling. So this is an example of stratified sampling without replacement, and this is how you cluster the data, group the data, and out of the group you decide some samples. This is called as stratified sampling. So with this, I will stop for today's session. We have seen different data reduction methods based on numerosity reduction. We have seen histograms, clustering, and sampling. The next one is called as data cube or data aggregation. Data aggregation is something like a statistical report. So instead of storing the data of all students, I am going to store some numerical value that is of individual's interest. Say for example, if you have seen your attendance reports, you might be able to find that there is one sheet in your attendance sheet where you sign, where all the students are listed, followed by their attendance in individual subjects. And there is one report page which is placed on top, which says how many number of students are between 50 to 65 percentage attendance, 65 to 75 percentage attendance, and 75 and above percentage of attendance. So that statistical report of how many students belong to each of this type is called as aggregation. So I am trying to find some statistical information, or I try to make sense out of the data that I have and produce only those statistical numbers for further analysis. Such a Now I have explained it for one attribute. The same process you can repeat for multiple attributes and you can form a data cube of the data that you have. So for class A, final A, you can have one aggregation. Final B, you have another aggregation. Final C, you have another aggregation. For all final years, you place an aggregation on top. Then for all third years, you place an aggregation. For all second years, you place an aggregation. So one over the other, you keep aggregating and you form a cube-like structure. Such is called as data cube aggregation. The last form of data reduction is data compression. Data compression, we all know there are two types of data compression. One is called the lossy compression, the other one is called as the lossless compression. In lossy compression, no data is lost. In lossless compression, in lossy compression, some data can be lost, but they may not carry any analytical value. So the original data is some very big size. Then you have the compressed data, which is of a very smaller size. So data compression methods can also be used for reduction of data. So with this, I will stop for today's session. In the next session, we will look into data transformation and data discretization. For now, I'm stopping this session. See you all in the next session. Stay home, stay safe. Looking forward to seeing you all. Thank you.